Welcome back. So today we're going to be talking about our pyramids and our cones. So same way as we started out with our prisms and our cylinders, we're going to be identifying and labeling some different pieces here, and then we'll move on to some examples. So starting out with our pyramids and our cones, again, the only difference between a right and an oblique. So a right pyramid, our center is perpendicular to our vertex. Whereas here, our center is not perpendicular to our vertex. Same thing with a cone. If the center is perpendicular with the vertex of the cone, then it's right. If it's not, it's considered oblique. Okay? All right, so then we're going to be looking here at vertex. So that is the first thing here. So we need to know where the vertex is. We have a vertex on both of these. The next piece is the base. So these only have one base. So we have a base here and a base here. Next one is our lateral faces. So our lateral faces are actually these flat surfaces here. So this is a lateral face. And then on this one, our lateral face is actually right here because it points to this whole face here. So lateral face. Next one is our lateral edges. Remember, edges are where the faces intersect. So this would be an edge here. So this top one is a lateral edge. And then over here, we've got it pointing to an edge here. So lateral edge. Altitude, remember your altitude has to be perpendicular to your base. So we have an altitude here. We also have an altitude in here. Those are both pointing to those dotted lines that are perpendicular with our bases. Slant height. Slant height, sometimes we have to use the slant height if they give us maybe an angle measurement in there and we have to find our altitude. But we don't use slant height an awful lot in volume. We use it more in surface area. But our slant height, that would be this one. I'm just going to put slant on both of these. Slant height. All right, so that's for both of those. So then the last piece is our volume. And again, the nice thing is volume for both a right and an oblique is the same. So volume equals, for this one, it's going to be 1/3 the area of the base times the height. Now the reason why it's 1/3 is because if you actually filled a pyramid with the same base as a prism, it would take 3 of these pyramids to fill that prism. Okay, so that's why it's 1/3. All right, so moving on to our cone. Again, we're going to label a few things here. So we have our vertex again is at the top. We have our base. Both of these. The axis, so the axis, if we had a triangle and we put it on the axis and spun it around, it would create the cone. So the axis, that's this dotted line, and it's just really faint on both of these, but this is the axis. So for a right, it's perpendicular, and for an oblique, it's slanted. So that's our axis. Altitude, like our height. So it has to be perpendicular to our base. Got my E over here. Okay, and then slant height, again, that's that slanted piece. And I'm just going to put H there because I kind of ran out of room. So then for our cone, very similar to the volume of our pyramid, it's going to be V equals 1/3. The only difference is, since we know that every base is going to be a circle, we're going to use pi r squared again, and then times h. So the only difference between these two is that we know that every base here is going to be a circle. Up here, we don't know what the base is going to be, what polygon shape it will be. So that's why we just put the generic capital B. Okay, so again, moving down here to this piece, how do we name our pyramids? by the shape of the base. And then how do we name our cones and pyramids? So oblique. Let's see. Vertex and center are not perpendicular. And if it's right, vertex and center are perpendicular. So if it's not perpendicular, it's oblique. If they are, then it's right. Okay? All right, so then we have some more pink and green sheets, similar to what we did with our prisms and our cylinders. So we're going to work on those next. So for these, again, we're going to be drawing our three-dimensional shapes, and then we're going to do an example. So we're going to start with our cone. That's our first one. So we're going to draw a cone. And we're going to label our center, and our radius is going to be 5 inches. And then we're going to label our height, and I'm going to call that 8 inches. We'll go ahead and label those. So then for our formula, V equals 1/3 pi r squared h. Okay, so from here, plugging in what we know, 1/3 pi r is my 5, so 5 squared. H is my 8, so I'm going to plug in the 8 there. All right, so this time I'm going to do my answer in terms of pi, so that's an exact answer. So we've got 1/3 times 5 squared times 8. And so I get 66 2/3 pi, and then my label is inches cubed. Then if I want an approximate decimal answer, I'm going to take that times pi, and I get volume is approximately 209. We're going to go 2 decimal places again, so 44. And that's also inches cubed. Okay, great job with that one. Let's move on to our oblique cone. So this time, remember, when it's oblique, center is not lined up with our vertex. So I have mine off to the side here, and you'll notice I made him, excuse me, let me scoot that up. I made him so that the vertex is straight above the side of my circle here, so it actually becomes a right angle. So we're going to have our height, we're going to say 12 centimeters, and I'm going to do a diameter this time. We're going to do a diameter of 12 centimeters, so all the way across. So volume equals 1/3 pi r squared h. This time our r, we have diameter is 12. So that means our r is 6. And our h is 12. So we can go ahead and plug that in. So again, I'm going to do my answer in terms of pi first. So I'm going to take 1/3 times 6 squared times 12. And I get 144. So that's going to be 144 pi, and that's centimeters cubed. Now to get my decimal approximation, I'm going to take that times pi, and I get 400, approximately 452. 2 decimal places would be 39, and that's centimeters cubed. Okay, great job with those. We're going to move on now to our pyramids. So I'm going to go ahead and close those up. Move over here to our pyramids, starting with our right pyramid. Drawing a picture of our right pyramid. So I'm going to do do a rectangular pyramid. He's an easy one to draw. So I'm going to have 10 inches. Let's go 6 inches, and then our height coming down with this nice little dotted line perpendicular to the bottom. We're going to have a height of 8 inches. Okay, so that height is 8 inches. So volume equals capital B times H. So for this one, our capital B is length times width. So we get 10 times 6 is my base. Those are my 2 dimensions for my base. And my height is 8. So that's what I'm going to plug into my calculator. 10 times 6 times our 8. Oh, and I almost forgot. 1/3 needs to go in front there. So make sure that we have that 1/3 there. We can't forget him. So 10 times 6 times 8, and we want 1/3 of that. I got 160 inches cubed. And then our oblique, going down here to our oblique. Again, when we draw our pyramid, we're going to put him off to the side just a little bit. I'm going to draw another rectangular pyramid. I'm just moving my center off to the side. Okay, so now from here, let's do 5 centimeters, 3 centimeters, and then to draw our height, I'm going to draw a little arrow out here, and this is going to be 4 centimeters. So volume equals 1/3. You can't forget that 1/3, base times height. So volume 1/3. Our base here is a length times a width. So volume equals 1/3, 5 times 3, and then the height of our pyramid is 4. So we're going to take 1/3 times 5 times 3 times that 4, and I get 20. So volume equals 20 centimeters cubed. Okay. Again, I do just want to remind you about what we talked about in relation to similar volumes. So we had talked about this in an earlier video, the volumes of similar solids. We have our volume 1 over volume 2 equals our scale factor cubed, because you will also have some volume of similar figures with your cones and pyramids. So I wanted to make sure to remind you of that on your practice problems. Okay, that is all that I have for you today. Have a great day. Bye.